Okay, today we're going to talk about adding fractions with uncommon denominators, which means that we're going to have to find common denominators in order to add fractions such as 2/9 and 5/6. So we already know that we have to find denominators that are the same. So the first step for finding common denominators between two different fractions is to list the multiples of both denominators. So what I'm going to do is I'm going to look at 9 and I'm going to look at 6. I'm going to come over to the side and make a little mini T-chart just like this. And I'm going to list out all of the multiples for 9. When I list out the multiples for 9, that just simply means that I'm counting by 9s. So 9, 18, 27, 36, 45, 54. I could keep going, but I don't need to. Now I'm going to list out all of the multiples for 6. 6, 12, 18, 24, 30, 36, and so forth, right? Then what we're going to do, after we have all of the multiples listed for each denominator, we are going to identify the very first one they have in common by circling it. So circle the first multiple that both, notice I said both, I put a little brightness on both, emphasis on both, denominators have in common. So we're going to come here, and I'm going to go through my list, 9, 6, 18, 27. Oh, I see that 9 and 6 both have 18 as denominators. Would you guys agree? Yes?
Yes. Yeah.
Okay. So 18 is going to be our new denominator. We also, because we're picking the smallest one or the very first one they have in common, this is called the least common denominator. You'll see that...
There's 36 and 36.
Yeah, there is 36 and 36. You're absolutely right. Some of you are noticing that there is 36 and 36. Could you use 36? Absolutely you can. But let me warn you, if you use 36, it will require you to reduce towards the end of working out the problem. And that's fine too. If you don't mind reducing, there's nothing wrong with that. It just adds one more step. So we've decided that we're going to use 18 as our new denominator. Okay. Now I'm going to refer back to 9. Okay. What did I have to multiply times 9 in order to get 18 in the first place? 2. 9 times 2 equals 18. If I multiplied my denominator by 2, I must also do the same to the top number. 2 times 2 is 4. So that's my new numerator. I'm going to do the same thing here. I'm going to refer to my denominator of 6 and ask myself, okay, what did I multiply times 6 to get 18?
3.
I would agree to that. I multiplied 6 times 3 to get 18. So guess what I have to do to my numerator?
Multiply by 3.
I must also multiply my numerator by 3. 5 times 3 is what, my friends?
13. 15.
Good job. Now I'm all set up to add these two fractions together. 4 plus 15 should give me 19.
Are we writing this?
Yes, please. 19, and my denominator is 18. What do we notice about this fraction?
The numerator is bigger than the denominator.
The numerator is larger than the denominator. So that means that we have to simplify this fraction back into a mixed number. So we can see that we have an improper fraction here, and I'm just going to write that off to the side. Improper fraction. And really, I've told you guys a million times that a fraction is really just a division problem, isn't it? Really, this means 19 divided by 18. Wouldn't you agree, guys? Right? And if I really wanted to get down to it, couldn't I just do 19 divided by 18, and all of us would see that that's 1 with 1 left over. Am I right?
Yes.
How do we show our remainders like 5th graders? We show them as fractions. So our improper fraction now for 19 over 18 ends up being 1 and 1/18. Okay? I feel like we should do one more example. That was a really good one. Good job. We're going to follow the same steps. Those of you who are watching virtually, please make sure that you are writing these notes as the video goes. Please feel free to stop and pause and write down whatever you need. Let me adjust my camera. We're going to do one more example. And this is going to be a subtraction one. 3/4 minus 2/8. Just because this is subtraction doesn't mean that we don't follow the same exact procedure. We're going to follow the same exact procedure as we did with addition. The first thing I'm going to do is I'm going to look at my 2 denominators, and I'm going to list out the multiples for those denominators. So I'm going to make myself a little T-chart off to the side here. And I'm going to list out all of the multiples for 4. So if I counted by 4s, I would start with 4, 8, 12, 16, 20, and I can keep going. We're going to stop there. Now I'm going to list out my multiples for 8. I'm going to start with 8, 16, 24. Do I need to keep going, really? Do I already have a multiple that I have? Do I already have a multiple in common?
Yeah.
What is the first multiple that 8 and 4 have in common?
8.
8. Good job. Thank you. 8. Now, does that mean that I can't use 16? Can I use 16 if I want to? Absolutely, I can. That's not a problem. I can use 16 if I want to. Yes.
You can do 24, but you did.
I can. But using the least common denominator, or the least common multiple, I should say, helps alleviate some of the reduction that might have to happen. So we've now decided that 8 is our new denominator, correct?
Yes. So that's how easy it is?
So now what I'm going to do is I'm going to ask myself, what did I multiply times 4 in order to get 8? Oh, why did I write 8? Sorry, that should be 2. If I multiply my denominator times 2, I must do the same to the top. 3 times 2 is?
3 times 2 is 6.
Good. In this particular case, because I'm already using 8 as a denominator, I just multiplied 8 times 1. So I have to multiply 2 times 1. Or you'll get to the point where you realize you don't even have to do all this. You just know that you're going to keep 2 8s the same. Now, is it safe to subtract? Yes. So 6 minus 2 is?
4. 8.
And 8 minus 8 is, oh, I'm sorry. Why did I just say that? Not 8 minus 8. the denominator stays the same.
Equivalent fraction would be a half.
I bet most of you are realizing that an equivalent fraction would be
So 2/4.
1/2. Because if you think about this, anytime a fraction has a numerator that is half of the denominator, that fraction is immediately equivalent to 1/2.
Oh.